So now we're asking for what is the measure of arc JN. And so we're looking for this arc right here. We just said this angle is 60 degrees from the previous problem. So what's the measure since the central angle is 60 degrees? What's the measure of the arc? Well, hopefully you can see it's also 60 degrees. Now we're going to find the measure of arc BC. So here's arc BC. This is a little bit different. This is a different problem, a little more algebra. So we've got this arc. What does AB look like? Well, if you said a diameter, then you're correct, because AB being a diameter will then basically mean that this whole thing is 180 degrees. So to find the measure of arc BC, I first must attack and find x. And so I need to know something, and since AB is a diameter, I'm going to say 2x minus 30 plus the x, that's all of this angle, must equal 180 degrees. And so adding these up, I get 3x minus 30 equals 180. And so now I just have to solve this algebraically to find out what x is. And then once I find x, I can go ahead and find BC. So I'm going to add 30 across the equal sign. And so 3x equals, looks like 210. And now if I divide by 3, x equals 70 degrees. And so equals 70. Well, that's just what x is. So this angle down here is 70 degrees. You have your options. If we're trying to find BC, since I know this angle is 70, and I've just assumed that this whole thing was 180, we could assume that this angle, it has to be 110, which would be the same as the arc out there. Or you could plug the 70 in for x. I'm going to go with the shortcut this time and say that BC is 110 because I know that this whole thing has to be 180 and this is 70 down here. But you can plug 70 in and get the same answer if you like. So then, same type of problem. This time we're trying to find the value of x, but they only gave us all of these x values around the outside. One thing that we know, what do we know about a circle? Well, we know that a circle has how many degrees? Well, it has 360 degrees, and so if we go around and know that this whole thing adds up to be 360, I could add up all the x's and set it equal to 360 degrees. So if I add these guys up, let's see, I get 10 and 17, looks like 24 x's equal 360 degrees. And now if I divide by 24, x is whatever. So if we take 360 and divide by 24, I end up with 15 as my value of x. And that's really all I was looking for. But the thing about that is if I know what x is, I could find any measure of any angle in there that I might need. Usually they're not just going to say find the value of x. They're going to say find the the arc length of ST or something like that. And so you'd have to plug in the 15 and work from there. So now what can we conclude from the diagram? State the postulate or theorem. So we're basically just going to go through and look at this. So let's see. We know that the arc length of AB is 90 degrees. We know the arc length of CD is 90 degrees. Well, from our theorem, from the theorem, I can't remember the theorem number, but it states that if the arc lengths are the same length, what do we know about the chord lengths? Well, if the arc lengths are the same, the chord length should be the same. So that's what we're talking about for C here. So AB should be the same as chord CD, even though they don't really look like they are. So then we have I think this is one last example. Oh, 2 examples to go. Sorry, I thought it was the last one. But we need to find the measure of ED, find the length of this side. Well, this is kind of a weird looking drawing, but this is also one of our theorems. And you'll notice that in our theorem it said that if we have a chord that is equidistant from the center, so 2 chords that are equidistant from the center, we have this chord is the same distance as this chord is, so ED is the same distance from the center as BC is, because we're measuring at a 90-degree angle and they're marked the same. So since they're measuring them at the same, they're measuring them at a right angle and marked the same, we know the chords must be the same length. So ED has to be 10. It matches this 10 that's over here. That's just following our theorems. Knowing our theorems is very important in this one. And then finally, we have that we're going to find the measure of arc EDC. So EDC is this one down here, and it's a little off from the center of the circle. You'll notice, so EC is not a diameter. We do know the chords are cut into 2 equal pieces, so that will help us a little bit. We know that if this is 60, this is 110, then most likely these chords are the same length since they're marked the same. That would mean that this angle is what in here? 110. This angle is 60, which would mean across from this angle is going to be 110 by vertical angle, since these are straight lines and they're the same chord. If I was to combine those two numbers together, that would give me the measure of arc EDC, which happens to be 170 degrees. And so that's really all we're trying to do, and it's just a matter of thinking our way through these problems and trying to come up with the different lengths that we need. So now they're asking us, this is our out for the day, and we're going to find the value of x. And to find the value of x, we just need to know a couple things about this. One, we have a diameter here that is meeting at a 90-degree angle. And I think we had a theorem that said if we have a diameter that meets a chord at a 90-degree angle, then it becomes the perpendicular bisector of that chord. So hopefully you can see that x has to be 7. And if you don't remember these theorems, please go back and look at them. Please write them down, make sure you have them, because you are going to need them for the test. Thank you for listening, and I hope you guys have a good afternoon.